Hello guys, this is Uncle DJ from Mathematical Series for Junior and Senior Secondary. Now let's try to understand prime numbers. A prime number is a number that has only two factors, itself and 1. Examples of prime factors are 2, 5, 7, 11, and 13. Let's try them one by one. 2. What are the numbers you can multiply together to give you 2? 2 times 1, and that is the only things that you can multiply together to give you 2. Only itself and 1 are the only two factors that it has. 5 is equals to 5 times 1. 5, you can only get 5 by 5 times 1. As it has only two factors. 7 has only two factors, 7 and 1. 7 times 1, itself and 1. 7 times the only way you can get 7 is 7 times 1. That's to tell you it only has two factors, and that means this 7 is a what? Is a prime number. The same thing with 11. 11 is equal to 11 times 1. So I want you to know something. 1 is not regarded as a prime number. Always note this. It's not a prime number. So these are prime numbers. Now with these, let's try to find all the prime numbers between 1 and 100. So these are the prime these are the prime numbers between 1 and 50. As your home task, I want you to circle all the prime numbers between 50 and 100 as your take-home assignment. And I want you to write all the answers in the comment section. Now let us go to the next question. Write your answers in the comment section. Now let's go to the next one, which is the prime factors. You know, we understand what factors are already, but this time around, and we understand what prime numbers are. We understand prime numbers and we understand factors. Now we want prime factors. Prime factors are factors of a number that are prime. For example, 42. We want to find the prime factors of 42. 42 has a lot of factors, but we want only the prime ones, the ones that are prime factors. So the prime factors of 42 are 2 times 3 times 7. 2, 3, and 7 are the prime factors of 42. If you multiply these 2 times 3, 6, 6 times 7, 42. 18, 2 times 3, 6, 6 times 3, 18. You can see, but all these numbers all these factors are what? They are prime. So to get the prime factors of a particular number, you use this method. That's what I'm going to explain here. You write 42 here, and you ask yourself, what is the smallest prime number that I can use to divide 42 without a remainder? And that is 2. The way you can know that is, anytime a number ends with an even number, just know that it is divisible by 2. Very, very easy. Now, 42 is ending with an even number, so you know it's divisible by 2. So you write 2. 2 in 42. 2 in 4, 2. 2 in 1, 2 in 2, 1. That's how we got this 21. Can we still divide 21 by 2? No, we can't, because it is ending with what is an odd number. So we can try another prime number, like 3. So now let's try 3. Can 3 go in 21? Yes, it can. How many 3 can we find in 21? 7. You write 7 under. Can 3 go in 7? No, it can't. So we try another prime number, which is the next one is 7. How many 7 can go in 7? 1. You write 1. So the final answer becomes 42 is equals to 2 times 3 times 7. And that's our final answer. That's how we got this breakdown. Or the factors of 42 are 2, 3, and 7. The prime factors of 42 are 2, 3, and 7. Now, let's do some couple of exercises. Find the prime factors of this number, 7,290, and make it a product of its prime factors, just like we did here. Let's try to do that. 7290 or 7,290 90. This is the answer. Now let me explain how we got this answer. First of all, we write 7290 inside, and we write, what can we ask? What can we use to divide this value without a remainder? First of all, you check, what does it end with? Does it end with an even number? Yes, it does. It ends with 0. So we can use 2 to divide it, which is the first prime number. So how many 2 can we find in 7? 3. 2 times 3, 6, right? Remainder 1. You put that 1 here, it becomes 12. How many 2 can you find in 12? 6. You write it here, 6. So how many 2 can you find in 9? 4, right? 4. 2 times 4 is what? 8. Remainder 1. You put that 1 here, it becomes 10, right? 2 in 10. How many 2 can you find in 10? 5. That's how we got this 5 here. Now, can we still divide by 2? No, we can't, because it has ended with an odd number. So we try to use another prime number, which is 3. That's the number that is after 2 is 3. Now, okay, now let's try 3. Can 3 go in 3? Yes, 1. How many 3 can we find in 3? 1, right? How many 3 can we find in 6? 2, right? Without no remainder. How many 3 can we find in 4? That's 1. Remainder what? 1. 3 times 1 is what? 3. Remainder what? 1. We now add that 1 to this 5, becomes 15. How many 3 can we find in 15? 5. No remainder. So good. Now let's try 3 in 5 is not possible, so we use 5. How many 5 can you find in 5? 1. That's how we got this final one. Once we got to 1, that's the end of the division. So 7290 is equals to 2 times 3 times 3 times 3 times 3 times 3 times 3 times 5. That's how we got all this. So instead of writing all these 3 like this, you can still write it as 2 times 3 raised to power 1, 2, 3, 4, 5, 6. You write at the top. That's in power form. 3 raised to power 6 times 5. This is our final answer. Now that we've worked on a couple of examples on prime factors, I want you to do this as your home task and write your answers in the comment section. The next video lesson will be on how to write numbers in index or power form. In that particular video lesson, first of all, I'm going to be giving you the answers to this home task. Then we now start with the topic of the day. I hope this lesson has been helpful. Thank you for watching and have a great day. See you in the next lesson. Thank you.